Well, hi and welcome to my shop, and thanks so much for joining me here. I'm just starting on this radio, a Halicrafters radio. Again, I really don't know anything about it other than what it looks like, and it looks kind of nice. Well, I do know a little more about it. I just checked on the internet briefly. This is not a well respected or particularly desirable radio, but it looks nice. I like the look of it. The metal cabinet, speaker mounted on the top here. It's got all its knobs, glasses there. Dial looks good. A little bit of rusty stuff here, but probably buff that up quite nicely. So a couple of switches here. For purposes I don't know. So this one says band spread, set to 0. And this is the other tuner here. Sometimes the way these work, there'll be places you stop the main tuning and then you use this one to spread it, but I'm not sure that's how this works, because look at the numbers, 0 to 100. So I don't really know what's up with this, but we could think of this as fine tuning, I believe. Ooh, feels like this is tightening up as I go. This one feels pretty good. So we have the broadcast band at the top, and we have 1.7 to 5 megacycles, and we have 5 to 14. So this is a really busy band, this one. And then we go back down again to 13, start over a bit, and go all the way up to 30. Okay, so getting up to 30 is challenging for these radios. Once you get above 10 megahertz, maybe 15, it's pretty tough on a little radio built cheaply to work well. So just an example of that is, to really be able to tune in these higher frequencies and get good selectivity and everything, generally you need to have a double conversion radio. But this guy's, I'm sure, is going to be single conversion, because I read he's cheap. Let's look at the back here. Again, it's in great shape. So this guy's been sitting somewhere very favorable all this time. There's no warp in this. The warp comes from sitting where there's moisture. So maybe, as this model radio goes, this is a good version of it right here. Screw missing here. Speaker headphone switch. Wow, okay, there's something I can get wrong for a while. It says phone in here. Phone, as in P-H-O-N-E. Phone, not phono. 30 watts. Underwriter Labs. This is American made, I believe. Radio and Television Manufacturers Association. I don't think I've ever seen one of those stickers, and I don't know what it would be there for. Great, should we just plug it right in? No. It's tempting because the radio looks to be in good shape, and I'll bet you we could plug this in, and I'll bet you it will make some sounds. But it's pretty easy to take the back off and have a look. Look at that plug. Holy smokes, man. That's the kind of plug you'd use to charge your car with. Wow. Assembled in Mexico. So, I can't imagine this is original. This doesn't seem original either. Although it kind of looks original through here. Ooh, it's really twisted up. Let's untwist it. So, it looks okay here, but not going to be for long. This is going to eventually fail here. But for now it's good. So let's take these out. 1, 2, 3, 4. Different size screw here. Looks identical. I wonder if there aren't screws coming up from underneath, probably grabbing the chassis, and maybe this is one of them. Definitely different. Maybe a big one goes at the bottom. The other, its brother is missing, so we can't know. These two are smaller. Put these in a little tray here. come out and drop down, and away it goes. Look at that. It looks like the same tubes from the radio I just finished. Same IF cans. Same vintage. That's what that means. Okay, so let's take a look inside if we can and see what's in there. This is looks to be, again, in really good shape. So I just want to point out something. I've mentioned a few times now that I've got Ted Rogers' bench meter here. Ted Rogers being a very significant person in Canada in the development of radio and television. Everybody in Canada, at least this part of Canada, will know about Rogers Cable. What they might not know is that the Rogers company also made vacuum tubes, because here's one. Rogers vacuum tube. Rogers bench meter right there. Mr. Rogers. Mr. Rogers is also a famous name here in Canada. Is it Canada or is it in the States? I never watched Mr. Rogers, but there was a children's show. Different Rogers entirely. Well, it all looks really good. I think we should just plug this guy in and see what happens. I have a safe way of plugging it in. If this is the first video of mine you're watching, the things you'll see me do in the shop, there are safety things behind it that I may not be talking about because, frankly, I have repeated it so many times on so many videos. So let's just see if we can get this out of here. I don't think this has been undone for a while. I want to do some of it, but not all of it. So for instance, the outlet I'm plugging it into here has restrictions on it. So if there's a serious problem in this radio, my shop will not fill with smoke. And part of the trick is putting the power through these light bulbs to get to the radio. That's what's going to happen. So let's rehearse. On/off switch. This is band select. Oh, here this is off. So it's probably the tone control, and they put the off switch on the tone control. No, it's probably volume. Yeah, that's volume. There's no tone. These are probably tone. Oh, it does say something up there. It says, what does it say? Way up there where you can't read it under that thing. Receive and AM. It says receive, and then it says AM. AM as opposed to what? Oh, CW. It says standby. I'll put it on standby. CW. So does that bring on an oscillator, like a beat frequency oscillator? Now, can you see this? Let me see if I get the right light angle here. So what I'm trying to show, and it's not coming up, is this backing plate is not a plate. It looks like some kind of paper, and it's actually got waves all the way through it, just slightly. And I cast the light across it, you can kind of pick up on that. So I don't know. And I wonder if this radio separates along here. It comes out the front as opposed to out the back. And what is holding the radio in? We're going to turn it on. Let's see if we can get it right out before we turn it on. Look underneath here. Ooh, that's painful. 1 foot missing. Oh, and we got a nice little thing here. Let's read this. For your protection, this receiver has been properly adjusted and sealed at the factory. Breaking these seals without written permission from the factory or dealer will void your RETMA. RETMA? R-E-T-M-A guarantee. RETMA. RETMA. What is that? RETMA. Replace and... I don't know what that means. This apparatus uses inventions of the United States patents of the Hallicrafters company and also is licensed by some other radio patent thing. Numbers will be supplied on request. And here's the tubes that are in it. 12SA, 12SG7, that's an oddball. 12SQ, 50L6, hey, can we just run across one of those? And 35L6. So it's very similar to the last radio. The difference really being this 12SA7. The other radio had a 12BE6, plus it had an RF front end on it. This is just a cheaper little AM around your house radio. This is supposed to be a communications grade radio, and it has no RF tube in the front. It's got a light. So the way this radio was described, and you know what, you just take this bottom plate off and we can see right in. There we go. Yeah. The way this was described on the internet was that it was basically a All-American 5. Yeah, this is an American radio, I'm pretty sure, so I can call it that. All-American 5 with a more complicated front end on it to enable all the different bands. So that's just about what it looks like too. Oh baby. Yeehaw. Wow. Well, this just doesn't match up with all the rest of the radio. The inside's been somewhere the outside has not been. Oh my gosh. So you can see white mildew growth on a lot of the wires in here, and that's a moisture indicator. These capacitors, they look like a horror story. This radio has one of, you can see it right here, maybe you can see that in the camera, hard to see, but it's one of these packages of the resistors and capacitors. These are problematic and difficult to deal with. Lots of resistors. The wiring is very unengineering like. It's just kind of all over the place in here. It does not look neat and tidy by any means. There are bare wires all over the place here. This stuff's on, there's a great big coil under here, and all the capacitors are mounted right onto it. It's kind of interesting. They've done that, but cheap is what's coming out of my head. Cheap. Great big high wattage resistor here. Looks good. There's quite a few of these ceramic capacitors in here. Now this one looks bad, but some of these other ones don't look so bad. It doesn't mean they're in good shape. It has its original big cardboard covered capacitor. So this is almost certainly one sick puppy here. And turning the radio on, we'll probably discover that this guy is just not up to the task anymore, and it'll be humming like crazy. The voltage here is 150 volts. The last one's a 25 volter, so that's going to be for a bypass on the output tube capacitor, output tube cathode resistor. That's what it would be bypassing. 150 tells you the P plus in this radio is probably 130 and lower. Probably 130 on the output tube. So I'm looking hard for anything that's burned open or looks stupid. Here's the wire. You know, this looks like a factory job. This looks like this is the original, but I don't think this plug is the original, but I think the wire is. What other little goodies can I pick up on here? Lots of things to adjust. Under here, all capacitors. IF is exposed there. Get the tool in, and the other one is up here. The wire running across it in a curious way. Got capacitors buried way down there. Got some mica, big square mica capacitors. Yeah, on the volume control here, this is the volume. A shielded cable coming up to the volume control. Shielding is soldered solidly to the chassis. see if we can figure out the chassis connections here. So I'm looking at things like this phone input to see how they're grounded, but in fact this is a two-pin input. What is that? A resistor across it. I guess that's to stop maybe when you have nothing plugged in and you switch it on. You have a funny hum. Don't want that. Antenna connections. So here I can see the ground here is soldered right back to the chassis. So I don't know how that's done. Is there a loop antenna in here? There's nothing in here. So what's the idea of this link? Well, I guess it depends. If you're hooking up a single wire type antenna, then you link this and hook the wire to here, to the what I imagine says antenna. What am I doing? Oh, this is the bottom plate. Right, the back plate. A1, A2, and G. G is the chassis. So A1, A2, and G, when we look at the schematic, we can figure out more about what they're doing, but there's nothing unusual going on. If we look at the negative wire coming from the big capacitor and ask ourselves, does it go to the chassis? I'm trying to trace it. It goes, I think it's going up on one of the terminals of the big high wattage resistor. I don't see any. It's okay, so now just look for chassis connections. Chassis, anybody hooked up? So here's one. This is hooked up to the chassis right down here. This guy may be involved with the draining of the chassis. Why would you have a capacitor? Well, maybe the chassis is used for all kinds of stuff. Doesn't look like it though. So I'm looking at it. You see, there's a wire soldered firmly to the chassis way down there. Capacitor to the chassis here. Okay, so something's going on with it. Yeah, some of these radios, they'll use the chassis to convey the AC voltage to the tubes. Ooh, they wouldn't do it in this one because these are all in series, I'm pretty sure. There's no transformer in this radio. Now that's one of the biggest signs that it's a cheapo radio. No transformer. Plug it in. I can do it safely. And so to do it safely, what I do is I use an extension cord. I go in the next room and plug it in. No, I'm just kidding. You know, this isn't really long enough here to do the trick. Just let this spew out. Okay, there we go. Yes, there's a light in here somewhere. Let's see if it works. Let's put it like that. Oh, should I put an antenna on it? Why not? Because I'm gonna. If it works at all, I want to put an antenna on it. So this can go on to anywhere in the chassis. Here, it can go on like that. It's the same thing as putting it on the screw. Okay. Now that goes to an outdoor antenna of some length here. I live in an ordinary house, an ordinary piece of property, but I have a wire that I run around the perimeter of the property, more or less. Are we ready? So in turning this on for the first time, the big issue is there a complete short in here of some sort, which would pop the breaker open in my house. I don't want that kind of thing to happen. So when I first turn the power on, the power will get to the radio through this one light bulb here. If there's a big short in here, then all the wattage will end up in the light. The light will come on bright, and we'll know not to do that again. Now, make sure the set is off, because we want to know that the off switch turns it off. That's an early thing that's worth knowing. So when I turn the power on, this guy will come to life here. And I don't know if you'll be able to see it or not, what it says. So there's usually around 125 volts available at this outlet from the output of an isolation transformer I'm using. And with the light in and a smallish radio like this, we could expect the radio to see around 115 volts, something pretty normal, because in fact I have a little extra voltage on my outlet to begin with. So turn this on. If the switch is off, and then we'll see this come up to like 124. Let's see. And this light won't come on. Which light? That light. Okay, so nothing happened with the light. Let's see, 122 volts today, 123 volts. So we know this is drawing no power. I'm going to cut the power off again. I'm going to turn the switch on. Volume low. Not that it matters at first. So this is critical now. Okay, watch this light. Yeah, normal. Put this on standby. The normal expectation is the light may come on a little bit. You can see it. Briefly go down, probably to the point where you can't see it, and then come back up. A little radio like this, all this is happening very subtly. So I'll probably see it, but you probably won't. So I will report. And keep an eye on this guy, if you can read that. There we go. So 104 means it's drawing power. And look at the light here. I can't see anything, so it's drawing a normal amount of power or a very low amount. So chance of a fire here, really low. Chance of it working, well, there's a good chance. So this is reporting 117 now. Should give it a bit of volume here. Here comes the hum. This on too long. Now it is on standby. Band change. No difference. I'm going to put it on full here. That's enough. Okay. No surprise in that. So that little test suggests that the filter capacitor we were looking at has got to be replaced. And to that note, on the last radio I used my last 160 volt 50 microfarad capacitors, but got a few more. I got 100 of them because I think a lot of radios I'm going to be working on require these. So I bought 100 little capacitors, and we're going to need 3 of them right in this radio. That's just to knock the hum out and then find out if the radio is any good. That's seriously the situation here. So when I'm doing this kind of thing, and normally I start every radio completely intent on repairing it, and normally I succeed at the end. Maybe not 100%, but pretty good. So this one I'm kind of questioning whether I should proceed further with it. I'm just questioning, and I think the answer is yes at this point. That's a nice little radio, looking radio. As a communications receiver, it may be crappy, but as a radio for somebody to play around with, tune around a little bit, pick up a few things on shortwave, this might be just ideal. It's nice and compact. Doesn't have a million tubes in it. Well, I'm going to change that filter capacitor and we'll give it another go. So the usual challenges of doing these capacitors applies to this radio. So, the capacitor has wires that come right out of it and then go to their terminals, and the capacitor is held in by this bracket. When I go to replace it, if I remove this capacitor and all of its wires and try to work from the terminals back, it's a bit of a nightmare fitting all these capacitors that I'm going to fit in here. So what I sort of end up doing, and I think this is probably the most common approach to this, I'm going to cut these wires close to the capacitor. I'm going to keep the wires. I'm just going to turn this, I'm going to bind some of these together and turn this into like a 3-part capacitor and just hook it up to the wires so it's sitting right here. and just I guess what I'm trying to say is I'm preserving the wire connections into the radio, and I'm going to connect to it. And as for stabilizing these guys later, these are pretty light. I'll worry about that later. I'm not going to worry about it now. To try anything else in replacing one of these, yeah, I think it's a disastrous journey. So let's see, I can cut those wires right now. And getting this capacitor out isn't the easiest thing either, because it's all riveted. Maybe it'll, well, I'll get it out of there one way or another. So I cut these wires. Why are there two yellow ones? How does that work? Two yellow wires? Come on. What are the colors here? Yellow, yellow. Oh, because they're both the same. 40s, they're both 40s. 60, 40, 40, 20. And I'm going to do 50, 50, 50, 50. That's where I'm going with this. Okay, let's nip them off. Here. Extra safety step there. Cut them all. And the black one, I cut it with a lot of length here. It's still kind of tight in there. Now, can I get this capacitor out of here? If I can loosen the bracket a bit. It wants to go this way. There's really no reason to remove it. You can just leave it as a reminder of what was. You know, I'm going to leave it. I'm just going to leave it there for now. Why even bother to push these wires out of the way? There we go. Okay, so I'm going to go ahead and make the connections necessary to hook up all those capacitors. I got a fourth capacitor for the bypass. Before we get too far into this, why don't we take a look at the service manual. I think I found the proper manual, S-38D. That's what's written on my radio. I don't see DM, DB, I don't see Mark 1A, Mark 1B, or Mark 2 anywhere, but S-38D, this will apply, I am sure. We'll just quickly scan down through some of this stuff. Antenna input, single wire, 52 to 600 ohm balanced, unbalanced line. That's what that link is for. Take the antenna link off, you can put a balanced line on there. Yeah, one way or the other. Anyway, tube and dial light. Rotate. Before attempting to make any replacement, rotate band spread control fully clockwise and the tuning control fully counterclockwise to prevent damage. So that's just to close those tuning capacitors so you can't wing them while you're reaching in with your clumsy hands. Ooh, lots of strings on this one. Don't even stop there. Just keep going. Alignment, just a quick look. Dummy antenna. Look at how complicated that is. Wow. Really? Oh. What? A 20? Yeah. Like we all have 20 microhenry coils handy. Speaker, voice coil. And here's all the stuff. High side through stator plates, front section tuning, ABCD, output meter 50 milliwatts. I've got the right meter for that. 50, no modulation. How does that work? What are you hooked up to? You're hooked up to the well, we won't worry about it right now. Can't worry about it when I have to worry about it. High side through that crazy dummy antenna thing. Boom, 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 boom. That's all. I think it's all pretty typical. Step 2, usually unnecessary. Ooh, what's step 2? Same as step 1. Hey, they're playing a trick here. Adjustment should be made only if a weak beat note is obtained on strong CW. Okay. I'm just looking for little things that I should know about now that are going to haunt me if I don't find out about them. Alignment stuff. Okay. It's a 2-section capacitor. What's that? Looking at the radio here. well, there's two. There's two tuning capacitors. So this one is probably the band spread adjustment, and this is probably the main guy. Very unusual. I haven't seen that before. You think of the band spread as a big whopping trimmer. Here's the schematic. Let's rotate this, and the thing we're interested in is the power supply right away. What are they doing here that's unusual? Probably nothing unusual here. So the light is getting its power through a tap on the heater of the rectifier tube. All these, here we come into the high voltage power supply, 60, 40, 40. What does that mean? That means B minus. So this means B minus. Chassis is shown differently. Good to know. So there's a B minus. Up here, here's the chassis connections up here in the front end of the radio. A couple here, and then we're back to B minus. Okay. That's helpful. What's this thing doing out here? Floating along in space. Oh, it's going between the chassis and B minus. So on the radio I just finished, this was a 0.08, and I stuck a 0.01 in. That was a bad move. I meant to stick a 0.1 in. So I'll try not to make that same mistake with this radio when I get around to it. But that's quite typical of how the chassis is tied into the radio circuitry. What other funny things have we got going here? AM, CW, switch. So there's some form of beat frequency oscillator in here somewhere. Receive and standby switch. Standby breaks the current here in the cathode, but it leaves the B plus in place. Does it? Oh, what's this one doing? Oh, that's AMC. It's not the same. Is this it? This is the receive standby switch. This is it. So all it's doing is just breaking the cathode connection here. So the radio goes dead at this point. That's how they've done that. I was hoping they were breaking the B plus, but if you're going to break the B plus, that's probably a multi-section switch and high voltage involved, stuff like that. Let's go to the radio. Nice diagrams of the coils here. So whopping coils in this radio. Here's a diagram showing what I call the package. Another word for that is couplet. Couplet. I think they call this a couplet because it's usually coupling something to something. I'm not really sure about that, but it shows you anyway. Oh, different couplet used on the Mark something or other sets. Couplet used on the Mark thing sets. Is these okay? So there is one of these in there, but we won't worry about it till we have to. Just know it's there. Wire gimmick. Look at that. My eye just caught that. Where is there a wire gimmick? It's going to be right there. Oh, look at them. So there's two here. So these capacitors are in the form of what's known as a wire gimmick, which is you just take two wires and put them close together, maybe twist them a little bit, and that's your capacitor. So when we spot these, and the first time I saw one of these things, I thought it was a bad actor, and I cut it out of the radio. That was a long time ago. In other cases, I've replaced these with real capacitors. And I think the idea of this is they put these in the radio, they twist them, a length of wire, to give more capacitance than what might be needed, and then part of building a radio is cutting back these capacitor twisted wire things until you get the operation you're after. Don't know if that's really true in this radio. They're not gonna tell us what they did. So any other special surprises? Look at the speaker here. So the speaker appears to be completely isolated from the radio. There's no feedback coming from here. Notice the output transformer is just a straightforward transformer on the primary side. Nothing going on there. So the take off. So when you flip to headphones, well, that's what phones means. It's an output. When you flip to headphones, how much you want to bet this is like a 600 ohm resistor here or something? I will bet. You flip to the headphone and you actually get more output from here. When you're using the speaker, you're using less of this. So the speaker... Oh no, wait, I'm reading this totally wrong. The speaker... How does this work? The speaker... That's it for the speaker, that little bit of transformer there. And all this is... Well, it's just a diagram, right? So, yeah, can't sweat on it. Let's see if I'm right about this. I think this will be a 600 ohm resistor. R14. Let's just go take a peek. R14, 15 ohms. 15. So regardless, so then what's the speaker? The speaker impedance was written way up here, wasn't it? Didn't they write it up here somewhere? Speaker. Headphone output says right there. Headphone output 15 ohms. So it's not meant for. I was wrong. Not meant for 600 ohm old headphones. It's meant for more modern style headphones. But just about anything would work in there. I don't think they're. I'm just looking for things that I better find now rather than later. But I'll bet you I won't find them all. So here's the bypass. 20 at 25. So that's one of the sections of the big capacitor which I've actually pulled out of the radio now. I took it right out. Is that an asterisk? Is that an asterisk? What's the asterisk all about? Part of couplet. Oh, so there we are. So now we know where the couplet is. It's usually right in this area here. Showing this. Is it just capacitors in there? 3 of them? This must be inside there too. Let's take a look at the couplet diagram. Capacitor, capacitor, it's all capacitors. Shield not used in circuit. So it looks like on some sets they put in these, a couplet with 3 capacitors and used all 3. In other sets they put in a couplet that has 4 and they just ignored one of them. That's what I think is going on there. Varies with tuning gang setting. What varies with tuning gang setting? Hey, that's interesting. What's varying? Look for a black triangle. It's probably going to be in the front end here. There it is right there. So what is this? Oh, so this is the grid voltage. Is this going to be the signal grid in this radio? Grid number 1. No. This will be the oscillator coils. And typically grid number 1 is with the oscillator. Grid number 3 should be the signal. Yeah, it's coming from back here. Let's see. So we're pointing here and saying bands 1, 2, 3 minus 0.3. Band 4. Something different. What's special about band 4? Bands 1, 2, 3 is band 4 the AM band. So I'm looking at the radio. They have band numbers. Band 4, no, it's just the top shortwave band. Band 1 is the broadcast band. So they must be doing something just a little different with that top end shortwave band that covers so much range. Any more gimmicks? I mean, I looked for these, I saw 2, I thought, well, that's probably all there is. But how do I know? I should really have looked through all this to see if there's more. I don't see any others, so maybe that is all the gimmicks. What else is on this interesting thing here? Chassis, B minus, band select, resistor ratings, half watt, capacitor values, micro resistance values, ohms. A 1.25 meg volume control will be found in some sets. If you find it, please return it to us. The 2 meg control shown in the parts list will serve as a replacement. So I think what happened here is they made a number of these radios using a 1.5 meg volume control, then decided 2 would be better. Put 2 in the parts list in the schematic and started making these radios with 2, and then it's in some sets. So it could be it was a little out of control when they made that change. So you can't tell you which sets. Sometimes they'll say, you know, between serial number of this and that, they'll find something or other going on, something peculiar going on. There's another one those asterisks. What? Part of couplet. Wait, what? Down here. Just goes to show how these schematics don't show you at all pictorially how things are laid out in the radio. And in fact, these images go in your head, and they aren't helpful sometimes when you look in the back of the radio. Okay, all these ones that are, like this couplet is very simple. All of these could be replaced with discrete components. No problem at all. Well, I won't say no problem at all. It might be a little bit of a space deal. Trying to get it in there. Okay, I think that's a good enough review of this. No, it isn't. Let's look at how they handle the ABC. Get that in our heads. So here, both plates tied together. Okay, and then we've got RF filtering to B minus. We've got this is a 1:10 ratio here, these two resistors, very, very typical. So they're peeling off most of the DC voltage that develops here and sending it on its way. They have a capacitor blocking it from the top of the volume control even. Bottom of the volume control is grounded. What's that? What's that? What's that triangle? Oh, this is about the volume control thing. Varying volume control. Yes, they do vary, don't they? So that's how the ABC is derived. It's just drawn out on this voltage divider arrangement here. Most of the voltage heading out through a big resistor, very high impedance when you get on this side. There's the ABC capacitor, and there's another big whopper resistor here. By the time you get over here, pretty high impedance back to the B minus. Well, there's a 500K resistor here right to the B minus. What are they doing here? So they've taken the suppressor grid and it's going to the chassis, not to B minus. So this is something I see in basically all radios. I don't fully get it yet, what's going on, but it seems like in the front end they want the front end, the antenna, all that to work against the chassis. So they often have just chassis connections, no B minus thing happening here. See, even this one's on the chassis here. And then further into the radio, it's all B minus. Look at that. Oh, so this is a shield that's going back to the chassis. I don't fully get it, but then you know what? There's lots of stuff here I don't fully get. If you're gonna wait until you fully get it, you're never gonna fix a radio. Okay. I think that's it. I'm not sure I'm going to find out any more about any of this stuff. 1, 2, 3 coils, big switch, letters, showing you its position. Good grief, I hope we don't have to deal with the switch, other than to clean it a bit. Okay, so what's the impact here with what I'm doing with these capacitors? Nothing. I can proceed with what I'm doing, no problem. See, by using these wires here that are left, so all these connections are made back for me. I don't have to worry about getting on these terminals and all that kind of nonsense. Okay, so we'll carry on. I'm ready. Oh, I think I have to stop, in fact, and go play with my cat. Okay, I'll do that. Well, it's early evening here. I finally made it back to my shop, and I've managed to replace those, or that, old filter capacitor. Let's see what I've done here. There's the replacement one sitting there. We can take a bit of a closer look. See what they really look like. So there's 3 of them are 50s, 47s really, and one of them is a 22. And that does it. So it actually went quite well. Wires are flexible enough, stiff but flexible enough for me to get away with all this. So there we go. Great. I'm going to try this radio out now and See if I'm making a good investment or not. Switch off. Go. Good. I'm guessing that there's no panel light on this radio. Try a little bit. Check these switches. I think we're on standby here. Standby, open the cathode circuit. Standby, receive, AMCW. Okay, so just take this off standby. Okay, now which band are we on? Band selector. I don't think there's any. Oh yeah, there's a number there. Is there a pointer? So this must be band 1. So this is a regular broadcast band. Sounds like there's nothing there. This is now band 2, the 1.7 megacycles to 5. Well, if it's working, we're going to pick stuff up here. Oh. Well, that's like, you know, let's say 2 point. There shouldn't be anything there. Let's keep going. I think we're on this band, band 3.
Escucha los programas y las noticias más importantes de Cuba y del mundo. Visita soundcloud.com y busca nuestros audios por demanda. Escúchanos donde sea y cuando sea, a través de la aplicación de SoundCloud para su teléfono.
That sounds like ham radio. We're getting close to a ham band right in here. What is that? Oh no, that's not ham. Picks up lots of stuff, I can say. I don't know where it's coming from or how it could be picked up though. So now that's the sound of a type of ham radio broadcast.
Zurdo de Panamá, Santiago, el que siempre castigaba a los cubanos. puertorriqueño. Pedro Perullo Fomental, la FIL.
This is like the best shortwave radio in the world or something. Getting a little quiet.
Very well written. Could be prophetic. That we may not be able to see New York. Escape from New York. Even Adrian and the other one, very well endowed up top. She lived in Manhattan for a while. She was on that disgusting Jew show Maud.
You know, I'm not even going to let that continue, but that's an example of what you hear on shortwave now coming from, well, I don't know for sure where it's coming from, but holy jumper. Unbelievable stuff. Unbelievable stuff. Unbelievable. So disheartening. So heartbreaking.
That we begin to see the beginning of the end.
There's
Because
Brother
you were
Astaire.
here, you were
So if this is where we are, it shouldn't be any of this shortwave on here. So there's something a little odd going on here.
Aragne. Le está golpeando después de romper su tapiz. Y Aragne está huyendo. Velázquez en...
What's up with this band switch? Oh, I got it wrong. I got it backwards. I got it backwards. Okay. Yeah, so that's band 3. So this is band 4 now. So we're up on this top one, and I don't think we're going to hear anything. We'll zip through it. It's a heck of a buzz. Okay, then we just checked 3. Now we'll check 2. No way. Oh, that could be in that broadcast band.
मैंने अपने खुदा से पूछा
This sounds like the AM band. Yep. It shouldn't have.
Right? 23 hours, 39 minutes.
So this is the Canadian time signal from Ottawa. It's about 400 kilometers from here, and they broadcast at 3335. And that's what this really is. I'm stunned. It's excellent reception. That's ham radio there. Oh, this has a. Let's see if that does anything. It's a CW setting. I thought maybe it would act like a clarifier. And then the top one would be the broadcast band.
Classroom management that is around the kitchen table. Talk about
There's a marker line on the dial, a little red.
School's over, you have to be nice and love your children again, right?
It is magnificent because it all falls together and you see how God sovereignly.
It's late enough in the evening here that longer distance AM stations are coming in. So during the day I get Canadian stations for 3, 4, 5, and then at night, especially with a better receiver, there's just an endless supply of American AM radio stations. It's got the civil defense marker there. There are other ones down here, 640. French station radio.
Clair là entre le bidet et le papier hygiénique, si je comprends bien.
Oui, c'est que c'est très variable, dépendamment du type de papier que je vais utiliser, du nombre de...
Struggling with this one.
In the express, a collision, and now 3 right lanes are blocked. Traffic is solid from approaching the 404, and the express collectors are flying through here, though, so make that switch if you can. Eastbound 401.
Well, things are going to have to be better in the second period. 13-5, the shots favoring the Red Wings. The opening 20 minutes, and Jonathan Bernier really was.
Wow. Holy smoke, I was not expecting that at all. That's fantastic. Oh boy. Why would I do anything more to this radio? Because it's easy. Because it needs a bit of a tune-up maybe. I could try a little tune-up on it. It does have old capacitors, but wow, it sure seems to work. That's really impressive. Holy smokes. Great. Wow. Okay. I'm pretty excited. Yeah, well, thanks a lot for watching, and
I'll have to decide if I'm going to do more to this, or maybe I can set this one aside and know it works, and I can do more to it if I want. But I have other radios to explore too.